summer extensions or whenever, so we can get your mastery taken care of. Make sense? Sweet. We are getting into the time span of lessons where we can move pretty darn fast, depending on like what exactly we're doing. So depending on how efficiently we cover things today, especially because today is only a single lesson day, we could totally have time for homework at the end of this. Not saying I'm going to try to move as fast as possible for us to do that, but I think there's something to be said about knocking out practice work here, especially because the rest of this week we're jumping through content pretty quickly. Thursday and Friday will also be double lesson days, but I have not chosen the homework problems from there yet. I ran out of time this morning because another situation that I was digging into. Yeah, Mallory.
Can you put the homework for Wednesday back there?
Sorry. Here, I'll put it down here so it's in the video for our friends. So Wednesday is, and it's over there on that. I know it's small. Like over there, you'd have to walk over to our homework board to see it. But from 223, we'll do 62, 64, 66, and then from 224, we'll do 79, 80, 81, 83. I know there's 7 problems, but those are all really good problems. I like them a lot. Connor. Sorry, what's your question? I need to know. So the objective is this year we will cover all of 7th and 8th grade math, but bounce back and forth as we go through the year. So it's not like we do all of 7th and then all of 8th. Like we do some 7th here, and then mix in some 8th, and then we do some more 7th.
What's that pacing for jumping through some chapters? Because I think we finish early.
It depends. Last year I ended up having to skip stuff at the end of the year because I did not move fast enough. So this year I'm trying to keep a good pace. I can't really answer that question yet. I'm not sure. And it's hard for me to plan very far ahead. Guys, I don't plan any further than a week out because things with Phoenix are very flexible. And like for all I know, I might lose a day here or there. Like the cookout schedule might get modified and I might end up not having as much class time. Very hard for me to answer like super long-term questions, which I'm kind of more of a short-term person anyways. I like kind of focusing on the here and now. So again, we're working decimals to fractions, a bit more on those skills. So today, again, if you want to abbreviate and put decfrac, like we did last week, you can do that. Sorry, Gwendolyn, do you have a question?
Yeah, are we turning in 2.1.1?
Heck no. No, you're going to keep that until I do a chapter 2 homework collection, which I always collect homeworks, pretty much always collect multiples together. So you'll probably hang on at 2.1.1 until the end of the week, most likely. Don't turn in homework unless I request it. I know it's a weird habit to get in if you were used to like turning stuff in on the daily in elementary, but yeah, please do not. Sorry, I gotta grab my little folder thing here to make sure we're doing the right stuff. So we are gonna practice rewriting our fractions in both decimal form and then in percent form. Some people like going to another fraction first. Some people like going straight from decimal into percent. It all kind of comes down to what ends up easiest for your brain. But real quickly, work with your team to decide with these 4 fractions, we're going to make the little triangles for them. If I'm going to convert 7/10 into decimal and percent, right, so I have 7/10 up here, and I could write 7/10 and draw a little picture in the middle. But like, how am I going to do that? What's the easiest strategy for me? Is it easier for me to go to percent first and then figure out the decimal? Is it easier to go decimal then percent? So for a moment, like maybe a minute, do those on your own, and then we'll talk with our teams and see, like, you might not do this the same way as a partner in your team, and that's okay. Right? A lot of right ways get to Florida. But draw those triangles for those, and we're going to do all 3 representations. Don't worry as much about the middle of the triangle. Don't worry about that right now. I care more about the points, fraction, decimal, and percent representations. interject and then encourage that you guys talk with each other. Let's say we're going to redesign currency, right? Which actually has been a talk for a while. That didn't work very well. And we are going to do away with the penny and replace it with a modification of the quarter. So we're going to make a coin that instead of having penny down at the bottom, we're going to add another lower currency coin. We're going to make another coin that's half of a quarter. So what would that coin be called if it was half of a quarter? Quinn?
An eighth?
An eighth, right? What's half of a quarter? It'd be an eighth. Now people would be like, oh, you need an eighth more, and that'd be awkward. Like your whole brain would have to change, right? But we're so used to quarter being the name of a coin, right? But it's actually a fraction, right? They named the coin based off the fraction. So an eighth would be worth half the value of a quarter, right? Which would be 12 and a half cents. But in decimal form, it's just 0.125. So that's a note worth kind of putting in your brain and memorizing with the list of fractions that you already know, is that an eighth is 0.125. Every eighth is 0.125. So to get 3 eighths, we could just take a quarter and put an eighth onto it. Or to get 5 eighths, what do you think I'm going to suggest that you do? Take a half and put one more eighth on it. So talk with each other, take like a minute or so, check what you guys have, and then we'll bring it back together. I'll probably use random cards, just for warning. It just makes my life easy. In case we ever have a sub, by the way, and I suggest to the subs to just use random cards because they don't know who you are. My first class of the day, yellow like the sunrise. My second class, you guys, orange. I'm just letting, because some of you guys will be helpful when subs come in. Second class today is orange because, you know, like as this, I don't know, I was just trying to find another color like yellow. My math 2 class, they're the tiny stack. It's not very hard, they're blue. But then my afternoon class, if you would want to tell them like, oh yeah, the other class in the afternoon, they're green at like, I don't know, end of the day. So just FYI, random fact for you there. Take 30 more seconds, and then I will call on people at random to help me.
Does it all have to, Mr. Hudson?
Yes.
Does it all have to be the same? Like for C, I did 3 fifths on the top. I wrote 3 fifths.
But then you
And
made
then
it
I
6
put
tenths.
0.6.
Yeah, that's fine. That is absolutely perfect. All right. So speaking of which, with our orange cards, Savannah, give me the other representations for 7 tenths and like the order that you went in. So did you go decimal first or percent first?
I went decimal first.
Okay, so our decimal here is 0.7, and I could put as many zeros out here as I want, which most you're like, okay, why? But Savannah, how do I go from decimal to percent?
You just take away the decimal point and put 0 for 70%.
So one strategy, I totally agree with you. One strategy is just bump the decimal 2 places. So if you have the decimal value, you bump it 2 places over, which is a nice strategy when given the decimal, because my percent over here in B is just 75%. Which, Teak, what about the fraction form up here?
Fraction form, I wrote as 3/4.
But what would we maybe have started at based off the decimal?
75 probably.
Yeah, so regardless of if you put 75 hundredths or if you put 3/4, or I mean, you could have put like, I don't know, there's a few other ones that we could utilize there. Like, well, there's, okay, if we're being technical, there's infinitely many. Um, I have a random question when we get done with this slide. Sorry, an interaction I had with a friend online. She's actually teaching in Hawaii right now, but she was trying to help a cousin of hers. Yeah, right. Teaching in Hawaii, that'd be fantastic. 3/5. I don't know. I'm trying to sit down. 3/5. So Simon, what did you write? Actually, what did you do first? So given 3/5, would you do fraction, decimal, percent? What did you do first?
I just did them clockwise.
Okay, starting where?
Starting from the first, like the one it's asking.
Yeah. Okay. So what's our fraction up here then?
Um,
So part C. Sorry, we're on part C.
oh,
So they gave us the verbal. Do you want me to come back to? Connor?
3/5.
Yeah, we could put 3/5, but a couple people as I walked around said, well, that wasn't that helpful. Actually, making that fraction into 6/10 was a lot more helpful, because then my decimal down here is 0.6. Yeah, well, okay, that's kind of obvious. And then again, if I want to put zeros or whatever, or just think mentally to bump that decimal, 60%. Now, with the extra note that I gave you, does anyone think that they can talk me through what this strategy, like what I was trying to get you guys to realize with this strategy of memorizing it an eighth? What's a half?
50%.
4/8, right? So if we think about this, sorry, I should have said just like anyone. If we think about this as a half plus an eighth. Well, what's the decimal for a half? 0.5. And if I know the decimal for an eighth, if I get that stuck in my memory of 0.125, I can just put those together. No calculator necessary. 0.625. Just add 500, or whatever number you want to think this is, with 125. We get our decimal form.
Whoa.
Same strategy available. Let's say somebody gave you 7/8. Start with 1 and just take away 0.125. Or again, like 3/8, go to a quarter and add the 0.125. Use that 0.125 to shift from wherever you already know. And then class, what's this percent?
0, 0,
62.5.
I did it.
Questions? All right, so I had a friend who was trying to help their cousin with some math, and they said, so I'm trying to get I forget what the kid's name, to understand that there are numbers between 1/2 and 3/4, that they're like our values that exist between there. And, I could not help but engage with this. How many numbers are between 1/2 and 3/4?
Infinite.
Yeah, I just wanted to make sure we think about this. There are an infinite amount of numbers between any two numbers. So I just want to make sure, like, this kid is a really small kid, right? He's like a child. There's no way he would understand even the idea of infinitely amount, like, that doesn't, yeah, getting complicated. That doesn't make sense in our brain. To have an uncountable amount of objects, it breaks our brain because we count things, right? Like, we as humans, we're used to counting things. We're used to counting chocolate chips even, like, oh, my cookie has more chocolate chips than yours. Like, you know you do that when you look at the plate of chocolate chip cookies. So there are, remember, as we dig deeper and deeper and deeper into mathematics this year, you're going to have to, like, let your brain get broken by some things. There are an infinite amount of numbers in between there because we could keep zooming in. Now, does that then mean that this space right here is the same space as the space between 0 to infinity?
No. No.
Maybe.
Yes,
Who knows?
Yeah, maybe.
Like, so that, and there's a lot of ways to ask this, but that will be asked often as, is the space between 0 to infinity the same as the space between 0 to 1?
Yeah.
Like, well,
If it's infinity,
Maybe.
Yeah, and it depends on how you interpret the question. So but we can't go down that route. So I already told you guys a bunch this year. I like to save paper when possible. This was gonna be a paper handout page, but I don't want to do that because that's 25 sheets of paper that I don't want to waste. So in your notes, please write down all of these decimals real quick and leave some space because we're gonna write the fraction equivalents. We don't need to do percent equivalents, but we're gonna write the fraction equivalents for all of these.
Wait, what number is it?
19. And then this should be fast. Just write the fraction equivalents exactly how you would properly read it. So my segue here is if you're helping your younger cousin, nephew, niece, whoever, at saying decimals the proper way, we would not say 0.19. That's not how we read that correctly. That's how we as mathematicians have made things really easy, because as you get really big decimals, like 0.58256, or like really big numbers, just like super complicated big numbers, it's hard to read them, but these should all be easy enough to read. We can call them the proper name. So just to get us rolling, let's do one together. How do I properly read 0.19? Okay.
0 and 1900.
Yeah, and this 0 and, that's actually a really good point. I should make this argument because I did it in the last class. And is often misused. And is the break between entire values and partial values. So this number is not 624, like so many people on TV say. I like hear these people talking like, go back to college, come on. This is 624 and 5 tenths. The and is the break. So OP said it perfect, 0 and 1900ths, but because it's 0, we could just say 1900ths. So do B through F on your own, verify it with your team. And is the break. Which also means if you're reading really, really big numbers, there's still no ands. It's like 624,364,874 and whatever person.
And it also breaks my mind.
That's why I became a teacher. Just never wanted to stop coming to school. You want to know the real story? My boss at scout camp gave me the idea. I worked at scout camp as a merit badge counselor. So I'm an Eagle Scout, and we did weekly reviews. And I was in my weekly review, and he was like, "What do you want to do after high school?" And I was like a freshman. I was really young, and I was like, "I have no idea. No idea." I said, "I'm good at math. That's all I know so far." Think about teaching. So think about going into education because you're a decent, like, when you teach merit badge, which is like, okay, I could be a good merit badge instructor, but a terrible teacher. Like, working at scout camp is not the same as working at a school. Yeah, he gave me the idea. Reverend Tim. Reverend Tim is the reason I'm a teacher. George. How do I properly write B?
Okay, so it'd be 391 over 1,000.
391 thousandths. Quinn, what about C? If I properly write that. 1,000. Now, if I want to take exactly what they had, I guess I would write 001,000. What? Just play with me. Like, play along with me for a minute. If I do that here, I'm going to have 019. But, Olivia, what's this go over? 1,000, right? So 19 thousandths. Sorry, Jesse.
Allie Brown to the office, please. Allie.
Jesse, what about D? Or sorry, E.
3/10.
3/10. And F, everybody. 524 thousandths. Now, we started a little bit of this last week, and I gave you guys more strategies than I should have. Crap, I meant to capture that. My apologies. Sorry. So, Jerome goes to write 0.73 repeating, right? Which actually, when we have the repeating decimals, we kind of have to say them in that whole wrong way because they keep going on forever. And he writes it as 73 over 100, but we know that's not true. Because 73 over 100 would be 0.73. So, what should he write and why? I'm trying to decide how to extend this. Yeah. And then what if, my real question here, because we talked about this last week, is what if then he also tried to write 0.03 repeating? So talk with your team, see if you can remember how to write 0.73 repeating as fraction form. And then what about if we had 0, 3? So it goes like 0, 3, 0, 3, 0, 3. So it's not repeating the 3, it's repeating the 0 and the 3. 0.03, 03, 03, 03. All right, see if you can remember. Take a minute or two. When you have your fraction prediction, do the division and check it. When you have your fraction prediction, do the division and check it. And put your calculator down. Then put your calculator down. Who figured out the appropriate fraction to represent 0.73 repeating? And then we're gonna actually have to have a little conversation about trust. Right? We're gonna have one of those big, deep kind of family conversations. George, what'd you figure out? 73 over 99. Now let's talk about trust. So everybody at your teams, we should have typed in 73 over 99 and hit enter. And guys, fractions are just the same as division. So if you have a fraction, you just use the division bar. So we get 0.73737377. Right, okay, great. What if I type in just 7 over 9? So 7 divided by 9, hit enter. When I type in 7 ninths, my calculator comes up with 0.777777778. We can only trust our calculators to the point of the math rules that we know. Now this calculator knows the same math rules, but it has other rules activated that we may not want activated. So George, so intuitively, said, well, that's because the calculator, it's rounding, right? We, for a long time, have been taught we should round numbers because when they go on and they get messy, we don't want to do that, and we round. Do not trust the last digit of a long decimal answer. So like if you get your answer of 150, don't come up and go, should I trust this 0? Yeah, okay, come on. Long decimals in your calculator are going to do whatever it can to try to approximate the number. If it needs to round, it's going to round. So when it like changes the last number Like actually, if your calculator went one spot further, your 0.73 repeating would be 737373774 if it stopped right there, which is not true. It would be rounding due to that 7. Don't trust it. Okay? That this is the big moment where people realize like, "Oh, wait. I'm smarter than my calculator because I know when to apply these rules and when not to apply these rules." We don't want to apply that to a repeating decimal. So, put your calculators down. Nobody touch them. Move on to 21 and see if you can help. Now, we're predicting. So be ready to erase. Hopefully we're not writing in pen. Predict what you think these would turn into as decimals. No calculators right now. We'll check them in a minute. But make predictions right now. So please write down the fraction first. And then write down the decimal that you think it's going to turn into.
Whoa!
I know, I'm so nice.
No, you're not.
Could we play Ask Me Anything here?
No.
If we get done with class early, sometimes I'll do Ask Me Anything. Where like you can do your homework if you want, but if because like we like to let you guys get to know us, so you're comfortable. I think like way at the beginning of the year maybe, but I don't think you guys were comfortable enough with me to really like ask questions. Because that whole like how did I become a teacher thing, that normally gets asked. And if you want to know the answer to the universe, I mean that's easy. It's 42. The problem is you must know what the ultimate question is.
What is the ultimate
I
question?
like that. I like that.
If you want the ultimate answer, you must ask the ultimate question.
It's a good
What is
movie.
it like?
The ultimate question is go away, I'm watching TV.
Oh.
That's essentially what the robot,
That's
like the
not even
computer
the
does.
question.
Like, yeah.
Not really.
Yeah,
That was only in the movie.
Yeah. I need to go back and read the book again. It's been a long time since I read that book.
Oh my god.
Hitchhiker's Guide is a
The answer
fantastic
was
book.
42.
Yes. To life, the universe, and everything, I
And then
think was the
tried to
question
get
they
the big
asked.
supercomputer to answer it, and the answer they came up with was 42 too.
Yep.
Like it's crazy.
All right, Gabe. If I have 19 over 99, what do we think that's going to be?
I thought it was gonna be 0.19 with a repeating 8.
19 with a repeating 8?
Yeah.
Now, why?
Because I thought that there was gonna. That's a good question.
That's a good question.
I forget my reasoning.
Okay. Now, we talked about ninths last week. So, like, if I gave you 8 over 9, that gives me a repeating 8. But I don't really have an 8 involved there. Any other predictions for what this might come out to be, Mallory?
0.19 repeating.
0.1, what repeats? The 1, the 9, or both?
Both.
Mallory thinks it's 0.19 repeating. Why? Because, because. That's right. Check it in your calculator if you want. Do not do any of the other ones, but you can check this in your calculator if you want. It's 0.19 repeating when I type in 19 over 99.
Because you taught us that.
Now, using that rule, yeah, some things don't stick. I'm glad it stuck for you. Some things don't stick on the first time for everyone. Using that rule, check what your group has predicted for B. See if you guys all have the same prediction. Talk to the group. I'll take it. You have a theorem or theory? Not for A. That's just 0.19 repeating. So if I wanted to write it out a few places.
0.2.
Gwendolyn, what does B become? Or what's your prediction?
3.91 repeating.
3.91 repeating? How'd you get bigger than 1?
391 repeating.
0.391 repeating, and that is accurate.
Totally accurate.
Brayden, what about C? 3/9. Yeah, 0.3 repeating. Bum, bum. Simon, what about D?
0.001 repeating.
Sounds like we're gonna start talking binary. 0.001001001.
Oh god.
0101. Viruses are so much fun.
Write a binary wrap 110011. So okay,
Do we need the conspiracy theory?
that's true. But why? Even if we don't like know how to explain what math is actually happening, if we're trying to apply a rule, and we brought this up real quickly last week, but I know like not everyone gets everything when we go through it the first time. What rule are we kind of starting to see here about the nines? And I'm not looking for like an actual answer. And how does that relate to E and F? So do E and F, make sure we have those done. And then check up here for your answers and we will keep talking.
So was 119 the same as 18?
Okay,
I put it.
I know.
Yeah, because I oh my god.
I missed two.
All my zeros. That is wrong. I got
For the meter stick, so you can like put it on the board, like on the chalkboard or whatever. And that's why those triangles up there and everything too. Circles are kind of tough. So I have your answers up here. E is 0.524 repeating forever, and F is 0.019 repeating forever. Now I heard a couple people ask, now wait, would F be the same as A? Now F is kind of like a merge of A and B. Right, because we have 999 on bottom, but we only have 19 on top. Can anyone explain, using your student vocabulary, like not talking from 30-year-old teacher up here, can anyone explain what's happening? Right?
Okay, this is just a guess, but I think. Well, then I lost my thought, so that's not helpful.
I have an idea to help you explain yourself. Yeah, we'll stop. So Braden, if you can't quite explain your thought, can you explain how I could figure out what this division would be?
Well, you just 0.54321.
You're missing one key component. Connor?
It's gonna be 0.000.
So wait, tell me what you're doing.
It's the same rule of the of like the 10 or the like 10 like 1/10 or one over 100 and you third to the decimal.
Okay.
0.001, but then it's repeating because of the nines.
Okay, I think there's still we got a little bit more to make before we get there.
What I did was I counted numbers on the top to 5 numbers, and then counted the 5 numbers on the bottom, and then saw how many numbers were left, and that's how many zeros there were.
The number on the top needs to be written. You with me, Braylon?
Yeah.
Okay. I'm just making sure because this is like big rule. The number on the top needs to have as many place values as the denominator. So I'm missing this place value here, I'm missing this place value here, and that place value there. Write this on your paper. I know it's nonsense, but write this on your paper real quick. This could win you $1 million someday. Bro, you never know what they're going to ask you on that whole Who Wants to Be a Millionaire show. What if they gave you like, what is 54,321 divided by 99,999,999? 0. 0, 0, 0, 5, 4, 3, 2, 1, and all of that repeats. Once we write the numerator with the same amount of place values as the denominator, we just take the entire numerator and repeat it. Now, an evil math teacher, and I contemplated, like, evil me and then normal me. So, evil math teacher would give you 54,321 divided by 99 million, and say, divide this. And you'd spend 10 or 15 minutes doing long division to find that starts to loop. And every so often, there are 3 0 stages that drop down and the division can't be done, so zeros go up on your line. And then we can start over. This is easier. Sorry, it may not be more effective. Like, I might realize, like, oh crap, I should have had them do long division and discover that. But the rule with division by 9s, 9 or 99 or 999 or any amount of 9s on the bottom, is just make your numerator have the same place values and repeat the whole chunk. Connor?
What if the new numerator is one or more place values than the denominator?
So you have to make it mixed first. That's a fantastic question. So, essentially what Connor's asking, what if the new numerator has more place values already? Like, what if we need to make it have less? So what if we had like 12 over 9 to show a really easy one? Well, that's really 1 and 3 over 9. So then it becomes 1 and repeat the 3. So you have to make the fraction part of it proper first. What? Sorry, Jeff. Fancy. Questions? Okay. I'm running out of time. We looked at this last week when I tried to blow your mind. This is just it written out, but last week we expressed like x equals our repeating value. Instead of saying x equals, they just show it to you. So they say, well, if we have a repeating decimal, we take away the repeating decimal, you end up with no repeating decimal. Yay! And then they work through, so we did this last week, that's why I'm going to run through it real fast. We multiplied it by 100 to bump the thing that was repeating over to the left-hand side of the decimal. So they start by 10, and then they say, well, that's not good enough because then it's like 0.3, and that doesn't work, right? So instead of multiplying by 10, if we multiply by 100, now I can take away this repeating chunk by subtracting just the repeating chunk, which leaves me with only 73, which leaves me with 99 of them. And guys, if you forget this, it's in the video from last week. Like I covered all this. So then what that means is to get, and this is why I used an x last week with the variable, to get the thing by itself, to get that 0.73 by itself, I want to get rid of the times 99. So I divide 99 on both sides, and that's how we get to 73 over 99. There's an algebraic process we can follow through. You can also Google like repeating fraction to decimal conversion. You'll find a bunch of images of this. Teachers have it done out and all written and everything. Hey, that's still highlighter. And that's pretty much all I wanted us to do today. That's it. So tomorrow we'll start to run real fast. And really that means I'm going to skip problems, so we don't actually work any faster. We just skip through the lessons. Have a wonderful day, guys. Please make sure you get your homework done. I don't know if we'll have a mastery this week or not. We might just have a week without a mastery. Have a great day, guys. Yeah, if we make it far enough into the week and you still haven't finished, I'll give you some class time, but yeah, we'd like you to do it AO if possible. What's up?